Crash Course Instrumentation, Episode 5, Indicators, Recorders, and Alarms. Welcome back to Crash Course Instrumentation. In this final episode of our Chapter 6, Instrumentation Fundamentals series, we're rounding things out with a look at the devices that speak to the human operator: indicators, recorders, and alarms. Think of these devices as the user interface for instrumentation systems. They don't control the process, but they help people understand what's happening, track what happened, and respond when something's wrong. Indicators. Indicators are real-time visual displays of a process variable. Common types include analog dial gauges, like pressure gauges or temperature bimetals; digital displays, showing precise measurements; panel meters, integrated into control cabinets. Indicators can be found in nearly every industry, from a pressure gauge on a propane tank to digital temperature readouts on a refinery control panel. Field techs rely on indicators for first-line diagnostics. They're often the fastest way to verify if a system is behaving normally or if something is out of spec. Good practice includes positioning indicators in easily visible locations, using color-coded scale zones for clarity, regular calibration to prevent drift, selecting a range that is about twice the expected operating value, so that readings typically fall in the 50% span of the dial. This improves accuracy and readability while protecting the gauge from overpressure damage. Today, you'll find indicators embedded in PLC panels, HMIs, and even wireless tablets. But don't overlook old-school dials. They're still trusted in field service for their simplicity and ruggedness. Recorders. While indicators show you what's happening now, recorders track what happened over time. Traditionally, recorders were strip chart or circular chart devices using pens and paper to draw trends. These are still found in regulated industries like food and pharma, where hard copy backup is required for audits. Modern recorders are often digital and feed into a data historian or DCS database, which allows operators and engineers to analyze trends, optimize performance, diagnose issues retroactively. For example, if a reactor overheats at 2 a.m., a digital recorder helps pinpoint whether it was due to rising inlet flow, sensor failure, or controller drift. Case in point, the 3 Mile Island accident, 1979. In Pennsylvania, involved a partial nuclear meltdown. One key contributing factor? A critical valve remained stuck open, but operators misread the situation due to misleading indicator lights and a lack of reliable real-time feedback. Better instrumentation and record-keeping could have revealed the true problem earlier. In modern systems, recorder data is used for maintenance planning, energy optimization, root cause analysis after trips or shutdowns, alarms. Alarms alert operators when a measurement crosses a critical threshold. There are 3 main types: local alarms, buzzers, lights, or horns near the equipment; panel alarms, shown on HMI screens or annunciator panels; system alarms, logged into SCADA or DCS with timestamps and escalation options. Each alarm includes a set point, such as a high limit for pressure or a low limit for flow. Some are configured with dead bands or delay timers to reduce nuisance trips. Many plants use an alarm hierarchy, prioritizing safety-critical alarms, environmental compliance alarms, process optimization notifications. Over-alarming can be a serious issue too. If an operator sees 100 alarms every hour, the critical ones might be missed. That's why alarm rationalization and prioritization are part of good system design. Historical example: in 2005, the Texas City Refinery explosion killed 15 and injured over 180 people. Among the causes were poorly calibrated level indicators and ignored high-level alarms on a blowdown drum. The data was available, but due to alarm flooding and poor visibility, operators couldn't respond in time. This tragic event led to widespread industry reforms in alarm management. These devices may not move valves or adjust set points, but they're crucial in closing the loop between the process and the people who manage it. Best practices include regular alarm testing, clear and consistent labeling, integration with operator training, trending and alarm reviews during shift handovers. This wraps up Chapter 6 from Lessons in Industrial Instrumentation by Tony Kuphaldt. You can read the full open-source textbook at the link below. Stay tuned. We'll begin the next series soon with even more hands-on systems and signal strategies. Like, subscribe, and keep learning with Crash Course Instrumentation. Explore the full text. http://biblio.org/Kuphaldt-Socratic model. Watch all episodes. www.youtube.com at Crash Course Instrumentation. Join the discussion. www.facebook.com/groups Crash Course Instrumentation.